So these first four are just more of like the Quizlet practice we were doing, just almost sort of like an intro to the notes. So let's go through these together. This is asking to what power would give you 32? Like the logarithm is the exponent. So what would that be? 5. Good. 2 to the 5th will give you 32. If you want to count on your fingers, it's 2, 4, 8, 16, 32. Then you'd have 64, 128, etc. All right, how about this one? It got flipped. So -1. Negative is what reciprocates it. 6 to the 1st is 6. This one's also going to be negative because you have to flip that 1/3. -3. Good. And do you feel like your instinct kicks in? It's like I feel like that's going to be 3. Just negative because it's flipped over. And then this is 3 to what power would give you 9? 2. Okay. So again, the idea is that you're looking for the exponent, and that's why we drill the Quizlet practice just to do that over and over again. So we're going to write out our log properties. As a heads up, this is sort of like I hate to say this, kind of like a boring topic. So try to stay with me. It's really just a lot of symbols and understanding what the symbols mean. Okay, so just hang in there with me. Okay? And a lot of these are intuitive, you probably already know some of them. The first one, log base A of 1 equals 0. I put an A there because the base could be any number, like log base 2, log base 5, log base 10, whatever it is. But why is that 0? Yeah, anything to the 0th power is 1. Now, when you write it with the natural log, it will look like that. It's log base E of 1 equals 0. And I always write the ln ones separate because they tend to bother people because it just sort of looks different, but these mean the exact same thing. This one just has a base of E, which again, how much is E? About 2.7. It's about 2.7, kind of like how pi is 3.14, then you're good. All right, how about log base A of A? If you had log base 2 of 2 or log base 7 of 7, 1. Anything to the first would be itself. If you relate that to the natural logarithms, it would be ln of E is 1. E to the 1 is E. Or you could think of it like ln and E cancel out, they're inverses, they undo each other. So it's another way your brain can do that. Which leads me to this one. Log base A of A to the X. So the log base A and the exponential base A cancel, and you just get X, whatever that exponent is. Because again, what you're looking for is the exponent, so that's your answer. With the natural log, it would look like this. And again, that means the exact same thing. I just write it separately because, again, the ln, it looks different, so it tends to bother people. So these mean the exact same thing. And then the last one, if log base A of X equals log base A of Y, then what do you think you get to conclude? It's one of those if-then statements. If this is true, then what do you get to, conclude? Log base A of X equals log base A of Y, then what would be true? Yeah, X equals Y. If these have the same base, then X is going to equal Y. Now, if this was log base 4 and this was log base 7, that would not work. You get what I'm saying? They have to be the same. And to relate that to the natural log one, if ln of X equals ln of Y, then X equals Y. And again, those two statements mean the exact same thing. It's just the ln one looks different, so I write it separately so that nobody's confused. So relating that to these, and the next time we play Quizlet, I have another version of it that includes all of these kind of ones. So there's going to be more problems in the problem bank because I put in ones like these now that we've covered it. Log base 4 of 4 to the 5th. What do you think? 5. The trick is to not overthink. This one would be 1. Now here, ln and E cancel, but it's not 4, it's -4y. Got fraction, it got flipped over. How about this one? 0. Anytime you see a 1 there, no matter what the base is, it's going to be 0, because anything to the 0 power is 1. And then here, the exponential base 12 and the log base 12, they cancel, they undo each other, so the answer just is 45. If you're like, that's it, yep, okay? Now these say solve for x. So we're solving equations. Now I want to remind you, I brought this up before, but let's bring it up again. You cannot log 0 or a negative number. You can't do a log of 0 or a negative. If you try, it just won't work. You can go back to that lesson if you want, or you could just like trust me. But you can't log 0 or a negative. Do you remember when we did the rational equations and then at the end we had to go and check if they were one of our troublemakers? It's like that. When you get your answer, you have to go plug it back in and see if it's going to make it 0 or a negative number. Okay. Look it. Do you see how they're both log 3? Okay. That means this part is going to equal this part. If they were different bases, it wouldn't work. But because they're both 3, you can set these equal. So you're going to get x squared plus 3 equals 19. And then you just solve it from there. Like, welcome back to Algebra 2 class. What would you do? I guess you could do either way. You could subtract the 3 or subtract the 19. I'll do whichever way you guys. You want to minus the 3? Okay, so x squared equals 16. It would actually work either way. We feel very strongly about it. Either way is fine. If you felt that you liked the other way, you can do that. And then you square root. So what's your square root of 16? Plus or minus 4. Now let's check them. It's okay to get a negative answer as long as when you plug it back in, you're not doing a log of a negative number. So look, let's do positive 4 first. 4 squared, 16 plus 3, 19. That's positive. We're good. If you plug in negative 4 squared, 16 plus 3, 19. So you get to keep them both. Again, you can have a negative answer. You just can't get a negative logarithm when you plug it back in. Okay. Do you see how these both just say log? What does that mean the base is? 10. Good. Base 10. We have 10 fingers. Okay. So since they're the same, you can set these parts equal. So 2x minus 11 equals 5x plus 1. That's an Algebra 1 kind of problem. Welcome back to Algebra 1 class. I love to say that because like once you get through the step that's the pre-calc, like the pre-calculus stuff, then you're back to like something you've learned previously. All right, then what? Minus 2x, you'll have negative 11 equals 3x plus 1 minus 1, and we get negative 4. Now, it's okay to get a negative answer as long as when you plug it back in, you don't have a negative in the logarithm. So let's test it. 2 times negative 4, negative 8 minus 11 is a negative, and you can't log a negative, so we get rid of it. And so what's your answer? No solution. If you put undefined, I would accept that. That's fine. No solution. Give me a number. That won't work. Give me another number. That won't work either. That won't work either. Yeah, like no number on God's green earth is going to work. That's what a no solution is. All right, these both say ln. What does that mean the base is? E. And because they're the same, you can set these parts equal. So we get x squared minus 3x equals 10. Now, there's not an either or kind of thing for this. There's one way that you have to solve this. This is like an Algebra 2 kind of problem. What would you do? Yeah, we're going to have to factor. So what do we do first? Move over. What do I call this? Evacuate. Get everybody over. Subtract the 10. Make it all equal 0. And then, yes, we're going to factor. So that would be x and x. How would you split up 10? 5 and 2. And good, you guys even said the signs. Negative 5, positive 2. So your potential answers are 5 and negative 2. And again, you can have a negative answer. You just can't have a negative inside the logarithm when you plug it back in. So 5 squared is 25. Minus 15 would be 10. That one's good. If we plug in negative 2, this is the one that's kind of trickier. That'll be positive 4 plus 6, which is 10, which is positive. So we're good. We get to keep them both. W. Okay, I'm going to go through these the other formulas here and do a proof of one of them. I'm not going to prove all of them. I'm just going to prove one of them. But I like to show you where these come from. And again, this is going to look like the alphabet threw up on your paper. Just stick with me, okay? When we go and do the actual problems on the other side, it'll make more sense, but I have to like give you the information first. There's 4 of these. If you're like, how many of these are there? All right, log base A of u times v. You're going to have u's and v's in this, so try to make your u's really curvy and your v's really pointy, okay? Log base A of u times v. So if you're multiplying 2 items in there, when you separate it into 2 separate logarithms, you're going to add them. So it'd be log base A of u plus log base A of v. And please listen very carefully to what I'm about to say. We did not distribute a logarithm. That's not a thing. You can't do that. If you do this on a test, do you know how there's like right and then almost right and sort of right and kind of right and then like sort of more wrong, and then that is like so wrong. There is no partial credit I can do for you. Do you understand what I'm saying? Don't do that. I hammered this hard last year and no one did it on the test. I was super excited. Do not distribute that. That's not a thing. We used a formula. Okay. Next one, log base A of u divided by v. So quick question, use your common sense. If when we were multiplying, we added them, when we divide, what do you think we're going to do? We're going to subtract them. Good. Log base A of u minus log base A of v. It does kind of sit well in your common sense, and I'm going to do a proof of one of them and show you why it works. And it's like, oh, I get it, you know. All right, log base A of u to the nth power. So when you have an exponent there, what you're allowed to do is take that exponent and bring it down and write it out front as the coefficient. So it would be n times log base A of u. So you're allowed to take that exponent and bring it down and write it out front. And then the last one is called a change of base formula. So if you have log base A of u, say A was 2. Say you didn't want it to be log base 2. Say you wanted it to be base 3 or 4 or 5 or something else. This is how you change it to a different base. So instead of A, say you wanted it to be B. It would be log base B of u divided by log base B of A. The reason why we need that formula is, and you're probably not going to care, but these calculators now will do any log base you want. Here, let me show you. When you go into the math menu, there's a button that says log base. Did you use this in Algebra 2? Or you guys are into Desmos now? Yeah, sorry, that shift happened. Okay, well, anyway, do you see this thing that says log base? And it can do any base you want. You can put any number there that you feel like, okay? Well, back in the day, like when dinosaurs roamed the earth, before that they updated these, the only 2 logarithms the calculator would do are base 10 and base e. It would only do log, this one's log base 10 and base e. So if you wanted to type log base 3 of something in the calculator, you had to change the base to either 10 or e. It was the only way you could type it in. So that's like why it's kind of antiquated now, but anyway, I'm going to do a proof of just the first one. Stick with me. We're going to let x equal this. Try to look at just that and nothing else. What's the base? A. So it would be a to the x power equals u. I just wrote it in exponential form instead of logarithmic form. A to the x power equals u. We're going to do the same thing with this one. How would I rewrite this one in exponential form? Yep, a to the y power equals v. Okay, and I'm just going to prove this first one. So we're going to start with the left side. A proof means you start with the left side and you meddle with it until you get it to equal the right side. So we're going to start with that left side. Log base a of u times v. And you kind of just mess with that and see what you get. Well, what did we just say u and v equal? Like, what is u equal to? A to the x, good, and then v is equal to a to the y. So what the first thing I'm going to do is replace those. I'm going to replace u with a to the x and v with a to the y. I know you're like, the alphabet threw up on my paper. I get it. You'll be okay. I like to go through the proof of at least one, because usually like at least a few of you will have like a aha moment and be like, oh, I get that's where that comes from. So whenever you multiply, what do you do to your exponents? We did review exponent rules a couple classes. You add them. So this would be log base a of a to the power x plus y. Whenever you multiply, you add your exponents. Those are your exponent rules. I think you learned those back in Algebra 1. And then what do you notice? It's a log base a and an exponential base a. So those are going to, they'll cancel. And so you just get x plus y. And look back at the very first thing right underneath the word proof. What did x equal? Log AU plus, what did y equal? Log AV. So do you see how this equals this? It comes from the exponent rules. When you multiply, you add your exponents. When you divide, you subtract. When you do a power to a power, stick with me. When you do a power to another power, what do you do with your exponents? You multiply them. That's why you get to multiply these together. It's n times the logarithm. Multiply means add, divide means subtract, a power to a power means multiply. That's where they come from, and this is why. Okay? So your directions for these are going to say expand and condense. These are kind of like little puzzles. You're not actually really doing any math. You're sort of just rearranging them to expand them or condense them. If it says expand, you want to have several different logarithms. If it says condense, you should only write log one time. Does that make sense? Like the words expand and condense, make bigger, make smaller. Okay. And we're going to use the properties on the other side. Here it is in a nutshell. Anything that's in the numerator is going to be positive. Anything in the denominator is going to be negative. Because when you divide, you subtract the exponents. You're going to subtract the logarithms. So if it's in the denominator, it's been divided. And so you're going to subtract it. It's going to end up being negative. So numerator positive, denominator negative. That's like, if you felt like the other side of the paper was too much for you, that's it in a nutshell. Okay. So look at this one. Do you see how there's two items in the parentheses? You have a 5 and you have a y cubed. What's happening with the 5 and the y cubed? Are they being multiplied or divided? That means when we write the logarithms, we're going to add. Multiply means add. With me here? Okay, so it is going to look like this. Log base 2 of 5 plus log base 2 of y cubed. Did I distribute a logarithm? No, that's not a thing. I used a property. Since this is multiplication, I added them together. Now there's going to be one more step. There's nothing you can do with this first one. This log base 2 of 5. Nothing I can do to that. What that means is 2 to what power gives you 5? Anybody? 2 to what exponent would give you 5? Something. I don't know what it is without a calculator. It'd be 2 point something, like, because 2 squared would be 4. A little bit more than that would be 5, but I don't know what it is without a calculator. So just leave it. This one, do you see that 3 as the exponent? You're allowed to take that and bring it out front as the coefficient. So it'll be plus 3 log base 2 of y, and that is your answer. Again, you're not actually like doing anything. It's like a little puzzle that you're rearranging. So just view it as like a puzzle, okay? Let's try the next one. Look inside the parentheses. There's two items. There's an x and an e to the x. What are they doing? Good, multiplying. So whenever we write it as two separate logarithms, we're going to add. It'll be ln of x plus ln of e to the x. Did I distribute the ln? No, that's not a thing. I used a property. Now you can't do anything with ln of x. That's sort of just what it is. But this one, do you see how the x is the exponent? Where can I put that? In front. Good. So it's going to be x. Oh, and then ln and e do what? Cancel. So actually it would just be x. The ln and the e cancel, so it would just be x. Like that's it. Look in the parentheses. There's two items. There's an x squared and there's a square root of stuff. What are they doing? Again, they're multiplying, so when I separate it, we're going to add. Okay, so it is going to be ln x squared plus ln square root of all that. And then you're able to take the exponents and write them out front. So how can I write this first one? Good, 2 ln x plus, ooh, a little tricky here. For a square root, what's the power? Close, close. 1/2, okay? So it'll be 1/2 ln of 1 minus x. If it was a cube root, what would it be? 1/3. Fourth root would be a fourth. This one has 3 separate items. You have an x plus 2, and then you have the x plus 3 squared in the denominator. The numerator, do you see how they're being multiplied? Means we're going to add. So it's going to be log of x. Ooh, and by the way, what's the base for this? 10, good. Plus log of x plus 2 minus, because when you divide, you subtract. So the stuff in the denominator is going to be minus. And I can take that 2 and put it where? In front. So it'll be 2 log x plus 3. Again, view it as like a little puzzle where you're just sort of rearranging anything. You're not doing any math, so to speak. It's really just understanding the symbols and everything. How many separate logarithms are we going to write for this one, do you think? 3. Good. Let's do the numerator. It's a square root, so what's the power? 1/2. So it's going to be 1/2 log base 3 of x. And then plus or minus? Minus, because we're dividing. And then what would we put for the next one? 3 log base 3 x minus 4. Good. We're just getting everything in the right spot. This one's still dividing, so it's still going to be minus. Again, anything in the denominator is going to be minus. And then what would that last one be? Good. You guys are getting it. Sweet. Again, just view it as a little puzzle. Now we're going to reverse that. We're going to condense them back together. That means you should only write log or ln if it's the natural log one time. You're squishing it back together. Okay? Adding means multiply. Subtract means divide. So for this one, you're only going to write log base 3 one time. And here's what I usually suggest. Draw yourself a big old parentheses, and then you can just decide where everything goes. Okay? So since we're subtracting, in here, we're going to divide. Draw yourself a fraction bar. It'll be x to the 4th over x to the 7th. And now that reduces a little bit. Sometimes with these, when you condense them back together, you have to reduce a little bit. How would you reduce x to the 4th over x to the 7th? Like some of the x's are going to cancel. Yeah, good. It'll be 1 over x to the 3. Mathematically, here's what happened. You have x to the 4th, which would be that. You don't have to write this if you don't want to. I'm just trying to visually show it to you. And then you'd have 7 of them. Do you see how 4 of them cancel? There's 3 of them left, but they're on the bottom. Good. Okay. Anyway, that's the answer. All right. Do you see this big plus sign there? Adding means we're going to multiply. Okay. So you're just going to write ln one time. Draw yourself a big old parentheses. When we did the expansion, do you remember when we took the exponents and wrote them out front? Now we're going to put them back. So this 4 gets put back. So inside of there, you're going to have 2x to the 4th. And again, we'll have to simplify that. Sometimes you get some simplifying that has to happen here. Times 3x. So I put the exponent back. We're doing this in reverse here. And now we just have to simplify what's inside of there. So you have to raise this to the 4th power. 2 to the 4th. Let's count on our fingers. 2, 4, 8, 16. So some of you just know it's 16. So 16 x to the 4th. And then it would be times 3x. And then we're going to multiply those together. So 16 times 3. 48 x to the 5. Good. Why 5? 4, and then another 1. 4 plus 1 gives you 5. Cool. This one has 3. Can you handle it? Think you can. Just write log 1 time, draw yourself a big parentheses. Anything positive is going to go in the numerator, negative is going to go in the denominator. So just draw yourself a big fraction bar and we'll decide what goes where. So this 3 gets put back. You would have x to the second to the third. That would be x to the what? 6. X to the 6th. And just hold on 1 second. All right, do you see how this next one is minus? Where does that mean it's going to go? On the denominator. But the answer is not negative. The negative just tells you where to put it. That's the common mistake I get. There's people put a negative in the answer. Don't do that. The negative just tells you where it goes. It goes down here, okay? And then you're going to put the 2 back. So it'll actually be x to the what? 10th. Good. X to the 10th. And if you're like, hey, we have to reduce that. Yes, sometimes you have to simplify. We'll do it in the next step. See this plus sign? That means it's going to go in the numerator. You're not going to put a plus sign. It just tells you where it goes. And when you put that 1/3 back, you don't want to write x to the 1/3. Oh, perfect. You guys have got it. Cube root of x. And then I'm just going to simplify that a little bit. A lot of times when you condense them, you have to simplify down. I'm not going to draw all the x's out on the paper again, but imagine 6 of them in a row and then 10 of them in a row and then them canceling. You'd have 4, but they would be where? On the bottom. Okay, so it would be x cube root of x on the top and then x to the 4th underneath. All right, last one of these. You're going to write log base 4 1 time, draw a big old parenthesis, and we're just going to decide what goes where. Don't put the pluses and minuses in the answer. They just tell you where to put it. So this 2 gets put back, and this part's going to go in the numerator. Can we go ahead and square that? Can you handle that? Okay, 5 squared, 25, and then x cubed squared. Good, x to the 6th. When you do a power to a power, you multiply. It's basically just all your exponent rules. This part goes in the denominator. How come? It's minus. Don't put a minus in the answer, just put it in the denominator. And if you put that 1/2 back, you're not going to write all of that to the 1/2. The 1/2 means square root. So it'll be square root of 2x plus 3. And there's nothing to simplify there, so we're just done. And then these last ones are that change of base formula. Again, it's kind of an antiquated thing now, but back when the calculators only did base 10 or base e, this is what you used it for. If you want to change it to base e, you're going to write ln, and it would just be ln 37 over ln 5. I basically just throw it in there to give you like an easy question. Do you know what I'm saying? Like that's the answer. That's all you have to do. So like, what would this one be? If you change it to base 10, you don't write the 10, you just write log. It would be log 41 over log 3. And like back in the day, that's how we had to type it in the calculator.